In this video, we are going to be talking about scatter plots. So the first most important thing is we have to know what a scatter plot is. A scatter plot is a graph that is used to determine whether there is a relationship between paired data. So basically you're looking to see if there's some sort of a connection between two different types of information. It doesn't mean that one piece of data forces the other to happen. It just means that there might be something connected. So there are three types, and depending on the type, they have a different name, but we're going to be talking about correlation to define these types. It's just how the relationship is between these two or more variables if you get real fancy and do more than two variables. The first one, the most common and easiest to understand, is a positive correlation. Oops, excuse me, sorry about that. As x increases, y increases. So if you have a graph, you're going to have a bunch of dots that look something like this. I don't know what the data points are going to be about because it changes from question to question, but we can see a general trend of going up and to the right. Okay. A negative correlation says as x increases, y decreases. It's going to be a very similar picture, just going down and to the right instead. Okay. It's basically positive slope and negative slope. The third type we're going to say is relatively no correlation. There's no noticeable pattern here. Okay. I'm drawing examples that are pretty nice because it can get real tricky depending on the information that we're given. So like in this red example, all those dots are close together. In the green example, all those dots are close together. That means we're getting close to r equals 1, close to r equals -1, and the blue one is close to r equals 0. Now, what is r? Well, that's our correlation coefficient that we'll talk about in a little bit. There is a range of values from -1 to +1 and everything in between. The closer you are to 1 or -1, the better the correlation. The closer you are to 0, the less of a correlation there is. So you could have a correlation of 0.1, which would be pretty bad. Maybe that looks kind of sort of positive, but just barely. So before we get into that and actually understanding that, we'll do a very simplistic example problem. So we're given a table, x, y's, plot some points. So part A, plot points. So we've got 110, 212, 315, 417, and 520. And it says sketch a best fit line. All that means is draw a line as close to all of these dots as you possibly can. There's my line. You might touch multiple dots. You might touch none of the dots. In this case, I'm going to say that I probably touched that dot and that dot. So if I'm writing my equation, hopefully you remember from Algebra 1, y equals mx plus b. If I'm going to go from this dot, I have to go up. And then, I went a little too far on that one. I have to go up and over. So I went up 5 and right 2. So my slope is 5/2, 5/2. Now to find what that b is, it would be nice if I could just say, well, it crosses right here. But I don't know that for sure because I'm hand sketching this. So I'm going to pick one of the two ordered pairs. I'll pick this one. And I'm going to plug that ordered pair in. So y was 12. And the reason I picked this ordered pair is because x is 2. So now, 5/2 times 2, those 2's cancel. I've got 12 equals 5 plus b. So b is equal to 7. And I get my equation of 5/2, y equals 5/2, x plus 7. That's my estimate of my line of best fit. This wasn't terrible to do because the numbers were nice, but we're not always going to get nice numbers. So now when it asks, what is our type of correlation? Just like our slope, it is positive. I think this is a pretty strong positive correlation because my line is very close to all of those dots. Now it says make a prediction for x equals 10. What that means is we replace x with 10. All right, now 5 halves times 10. I personally look at this as either 5 times 10 is 50 divided by 2 is 25, and then plus 7, or 10 divided by 2 is 5, multiply by the remaining 5 to get 25. Either way, you end up with a final answer of y equals 32. Again, these were nice numbers, so I'm going to show you or talk you through how to find it when the numbers are not so nice, even though we're going to use the nice numbers to start with. So in your calculator, if you don't have one in front of you, just kind of follow along. I got a picture next to these for us so we can kind of see the buttons we need to press. I put some screenshots in, so this takes up space, but it's a fairly fast process after you do it a couple times. So you're going to press the Stat button. It's just a button that says Stat, and you're going to get this Edit screen. Hit Enter to edit List 1 and List 2. List 1 is your X value. List 2 is your Y value every single time. So in List 1, I'm going to put my numbers. They were 1, 2, 3, 4, and 5. And the tricky part here is after every single number you put in, you have to hit Enter. Then I'm going to use my arrow keys. When I say my arrow keys, I'm going to talk about these 4 buttons right here. I'm going to scroll over to L2 and put in the next 5 numbers that we had, which were 10, 12, 15, 17, 20. You have to put them in the order that you are given because these are ordered pairs. List 2 is connected to L1. So after you get each number put in, you're going to hit the Stat button again. You're going to use the arrow button to the right to go to Calc, and the down button to go to linreg AX plus B. That stands for linear regression. And you're going to scroll down to hit Calculate. When you do that, your calculator should tell you y equals AX plus B. If it's newer, if it's older, it might not say that part. But it'll tell you A equals a number, B equals a number, R squared equals a number, and R equals a number. In this case, it told me that A was 2.5, B was 7.3, R squared was 0.99522, and a whole bunch of stuff. And R was 0.9976, a whole bunch of stuff. We don't care about R squared. Okay, in this class, we're not going to worry about R squared. That's for something a little bit different. This gives us an equation, 2.5x plus 7.3, which is very close to what we came up with. Ours was y equals 5 halves, which is 2.5x plus 7. Because our eyes aren't perfect, we're not going to always go through a dot that we think we're going through. But this correlation coefficient R, sorry, that 9 was bothering me. This is very, very, very close to 1. That tells us we have a very strong correlation, and it's positive, so it's a positive correlation. That's what that means. So if you look down here, it says, think of the R value like a test score. If you have a 90% on a test, you did pretty well. That's a really good test score. It's a really good correlation. If you got a 50% on a test, that's not so good. It's not as good of a correlation. The positive and negative number, just kind of ignore that when you're thinking of positive or the strength of the correlation. The positive is closer to 1, negative is closer to negative 1, but they're still close to the absolute value of 1. So think of those numbers as you would. All right. Now, if you want to see all of that on your calculator on a graph, what you're going to do is hit the y equals button, which the y equals button is right here. Oops. I'll give you a color you can actually see. You're going to type in the equation, and when you need to use x, you're going to use this button right there. So y equals 2.5x plus 7.3, and then you're going to scroll up using the up arrow to make sure you have the plot 1 covered and hit enter. That's going to turn on the scatter plot from your list 1 and list 2 you put in. Then you're going to hit zoom 9. That's going to bring the picture of your scatter plot right onto this screen, however it looks. So you can see the dot, and it'll show you the line that you drew, so you can see if it is, in fact, actually close to all of those dots. Okay, so the next question we have, it gives us a lot more dots, but doesn't give us a table. And I can't just go through the calculator process I just did because I don't know where most of these dots are. I can't have any way of knowing their exact ordered pair. So I've got to find ones that I kind of sort of think are pretty good, which would be those two. So I need to find the slope between these two. There are things that are going to work, things that are not going to work, and things that you think will work always that only work sometimes. In this problem, I can count slope. I went down 3, 1, 2, 3, 4, and right 4. So you can say your slope is -3/4. That is something that's going to work sometimes, not always. The reason why it works this time is because if we look at the dimensions of these squares, up, down, left, and right are all 1/2. If our scaling was different on the x or different on the y, counting the squares does not work. Then you actually have to do a little bit of division. But it's going to work fine here for this one. So I've got y equals -3/4 x plus b. I don't know what x is, so I'm going to pick an ordered pair. I'm going to pick this first one that I highlighted because x being 0 makes my life a lot easier. So I've got 3.5 for y is -3/4. X is 0 plus b. Means 3.5 is equal to b. And I don't want to have a fraction and a decimal in the same time. So I'm going to change that decimal of 3.5 to 7/2. Now, how did I get 7/2? Well, 3 is 6 divided by 2. 0.5 is 1/2. 6/2 plus 1/2 is 7/2. So I've got y equals -3/4 x plus 7/2. Another way, you can just identify 7 divided by 2 is 3.5. So 3.5 times 2 is 7. Same idea. For part B, it asks what is the type of correlation. Our slope is negative, so our correlation is negative. It's going down as we go further to the right. Now, question 3 is not technically more complicated, but it appears more complicated to most people because it's a real-world example where we have some shiftiness involved. So the table below shows the number of U.S. births from 2015 to 2020 in millions. Let x equal number of years since 2015. So that let x equal years since number 15 is the first tricky part. Since 2015, there have been 0 years until 2015. Since 2015, there's been 1 year to get to 2016, 2 years to get to 2017, and so on. Essentially, you are subtracting the year in the table minus 2015. That's the first thing. I don't want to have to put in 2015 as an x value, so we just shift over to where we're actually caring about and start with small numbers there. So in my calculator, I'm going to go stat, edit. L1 is 0, 1, 2, 3, 4, 5. In L2, that's where I put my 3.98, 3.95, and so on. Okay, I don't want to have to write out millions, so that's the second little bit of shiftiness that they did, is they changed their millions. So stat, scroll over to calc, down to lin reg. I'm going to write out pretty much the full thing it says here. Negative 0.072. B is 4.0033333, which is annoying. R squared equals a bunch of stuff that I don't care about. Remember, we're not going to worry about R squared. But R is negative 0.982746838. Now, you're not going to have to always use those long numbers, but I want to make sure that you see in your calculator what you should see. It should match this. But this is a line of best fit. This is a best guess, meaning this is an approximation. Since this is already an approximation, I can kind of approximate these numbers a little bit. So in this case, I'll say let's round to the nearest thousandth. I picked thousandth just because my A value stops at the thousandth place. My B value, I'm going to have to round. My R value, I don't really need to round because your R value doesn't show up in your equation. It just tells you if you're strong, if it's strong or not. So my R value, if I rounded it, was negative 0.983. That is pretty strong. This is a strong correlation that is negative. My equation is y equals negative 0.072x plus 4.00, and this rounds down to 3. There's my equation. So now, the simple question, which makes it harder than it needs to be sometimes, or it feel that way at least, says use your regression equation to predict the number of births for the year 2030. 2030 is x equals 15, because 2030 minus 2015 is 15. There's been 15 years since 2015 to get to 2030. So I've got y equals negative 0.072 times 15 plus 4.003. And I'm going to put that into my calculator. And it's going to tell me y equals 2.923, which is perfectly fine. But this isn't really what our answer is. There was not 2.923 people born, or there will not be 2.92 people 3. Wow, words are hard. There will not be 2.923 people born in 2030. This number is represented in millions. So my answer should be, there will be approximately or about 2.923 million births in 2030. You've got to make sure you think through what the question is asking so your answer is relevant to that question. If I put in numbers like 2030, for example, so I did all the right work, I forgot that it was 15 years since 2015, so I put in 2030, you're going to get a negative number. Logically, that should throw off a whole bunch of red flags that this cannot happen. So make sure you're thinking through what the answer is supposed to be, or what could be a relatively safe answer, what is a bad answer, so you can catch those things before you just move on. All right. Have a great day, everybody.